So in our last video, we introduced the sine inverse function, and in this video, I want to go through some examples of how to use it. So the first question here is to find the sine inverse of the square root of 3 over 2. So the first thing we need to do is to determine if the sine inverse function is even defined at this particular x value. So what that amounts to is determining if the square root of 3 over 2 is inside of the domain, which is -1 to 1 inclusive. So we've got 1.7321 is going to be the square root of 3, and we're dividing that by 2. So just reasoning, if we did 2 divided by 2, we'd get 1. So 1.7 divided by 2 is going to be a little bit less than 1. So it is going to fall into this interval. So the function is defined at this x value. So now we just need to figure out what it is. So what we're trying to solve is we're trying to find y equals sine inverse of square root of 3 over 2. So what does y have to be? Well, we're looking for an angle so that when we take the sine of that angle, we get root 3 over 2. So if we look at the first quadrant of the unit circle that I've drawn here, we see that the sine of 60 degrees is square root of 3 over 2. So that's going to be the y that we're looking for. And that's all we need to do. So as long as we are familiar with the unit circle, then these types of problems shouldn't be too bad. Next, we are asked to find the arcsine of -1. So for all intensive purposes, arcsine and sine inverse are going to be interchangeable in our course. So the first question we need to ask ourselves again is arcsine of x defined at x equals -1? Well, it has the same domain as sine inverse because they're the same. So -1 falls into that into this interval because it includes -1. So cool. So we're good to keep going. So if we draw a coordinate plane and we look for a -1, that's going to be over here. -1, 0, and got a 0, -1. This is going to be 1, 0, and then we've got 0, 1 up here. So what are we looking for? We're looking for an angle so that when we take the sine of that angle, we get -1. So we are actually going to be concerned right here. That's when the sine is -1, and that's going to happen at 3 pi over 2. So this is an interesting question. So it's tempting to want to say that arcsine of -1 is equal to 3 pi over 2. However, because arcsine has a range of -pi over 2 to pi over 2, then we need to use -pi over 2 instead. And these are coterminal angles. And so there's nothing wrong with using -pi over 2 instead of 3 pi over 2. The arcsine will still be the same there. Okay, so for this function, once again, we were looking for an angle so that when we took the sine of that angle, we got -1. Here that was 3 pi over 2, but because of the range restrictions, we need to write that as -pi over 2. Next, we are trying to find the sine inverse of root 3. So we ask ourselves the same question, is the function defined at this x value? So the domain, one more time, is -1 to 1. And so square root of 3 is 1.7321. So it actually does not fall inside that interval. So the function is not defined there, and there's no other work to be done. This does not exist. And if you were to try to type it into your calculator, you would get a domain error. So for our last example, just a different way to ask the same question we've been kind of going over, we want to know the sine inverse of tangent of pi over 4. So we want to know, is this function defined when x is equal to tangent of pi over 4? So let's figure out what that is. So tangent of pi over 4, we're going to need the sine and cosine of that angle. So we have the tangent of pi over 4 is going to be square root of 2, which is the sine, over the cosine, which is square root of 2 over 2. And since those two quantities are the same and we divide them by one another, we get 1. So the question is our function defined at 1? Well, once again, the domain is -1 to 1. It includes these endpoints, so it is defined there. So now what we're trying to find is we want to know the answer of y equals sine inverse of tangent of pi over 4, which is the same thing as y equals sine inverse of 1. So we're looking for an value, an angle, so that when we take the sine of that angle, we get 1. So here, that's not what we want. This would be the cosine inverse of 1 would be 0, which we'll get to in class on Monday. So what we're actually looking for is going to be pi over 2. The sine there is 1, and that's what we want. So y equals pi over 2, and that is in the range of our function, because the range of sine inverse is -pi over 2 to pi over 2, and so we are all good to go.